Hey, what's up, everybody? Welcome to Nine Vibes. So today what we're going to talk about, we're going to talk about the double slit experiment. It was an experiment that was done in 1801 by a physicist named Young. And so what he did is he took a photon gun, which is basically just a gun that fires off waves of light. Okay, so he took a photon gun and he took two slits and he fired his photon gun through the two slits, okay, to a wall. So if I were to take a baseball, all right, and I throw it at a wall, it's going to hit. Okay, so for instance, if I've got a wall here and I throw a baseball, it's going to hit here, may hit here, may hit here, may hit here, may hit here, depending, of course, on where I throw it. But if I were to throw a wave of water, well, then what's going to happen is it's going to hit here as one wave, or it'll hit here as one wave, or it'll hit here as one wave. So the difference between these is that this is a wave, okay, and this is a particle. Okay, so if we were to say that this is a particle of light instead of a baseball, that's how it would look if it hit a wall. If this is a wave of light, that's how it would look if it hit the wall. And the best way to explain this is that when you go through the double slit experiment, or when you go through the double slits as a wave, you kind of create a wave. So by the time it hits the wall, it hits it all the way from the top to the bottom. Okay, if I were to shoot a particle through this, then it's just going to hit the wall at a very specific spot. Again, same as if I were to throw a baseball. It's not going to hit in two different places. It's going to hit one exact place. Okay, so this was his experiment. The double slit experiment was that if you shot a photon gun of waves through it, it would hit the wall as waves, as you can see here. And if you shot particles of light through your photon gun, it would be very precise places. Okay, so when he turned his back, fired his gun, and did not observe what was actually happening, he got both. You got this one, and you got this one. He got multiple points where it clearly was a particle of light, and then he got multiple places where it was a wave of light. But when he decided to observe, okay, so what we're going to do is just draw a little eyeball here. Okay, so when he decided to observe what was going on, this is where it got very interesting, because when he watched it, before the photon would actually hit the double slit experiment, it would actually decide what it was going to be. He did not get two options of 1 and 2. He got only one. So he either got a solid point where it was hitting the wall, or he got a wave, which was like this. Okay, was not one or the other. So each one that he fired, he got a very specific answer. And so the most fascinating thing about this is that he also figured out that if you're not observing it, right, because he thought maybe his observation itself was changing the actual photon. So what he did is he brought in a camera. All right, so now you have a little camera that was watching. And the craziest thing is the exact same thing happened when he put in a camera. So whether it's being observed by a human that has an eye, or whether it's being observed by a camera that is watching it, the waves, right, the photons themselves are either going to become a particle of light or a wave. Okay, now normally we don't see waves of light. So that's what's so amazing about this experiment, is you could actually see the shadow of where the wave was hitting. Okay, we see particles of light, but we don't see waves of light. So what he learned from this experiment is that the observer, okay, which is you, or anything that's being observed, the observer is actually dictating what the photon is doing before it hits the wall. If he wanted it to be a particle of light, that's exactly what he would get. When he thought to himself, I want to see a particle of light. When he thought to himself, I want to see a wave of light, that's exactly what he'd get. He'd get these wave interference patterns on the wall. Okay, but the most amazing thing about this experiment that's not talked about is the fact that the photon gun is firing photons, correct? They're firing light. But at this point in time, we only knew about particles of light. We didn't know that a wave existed before. That's the most amazing thing about this, is that before the particle decided, okay, this is the 1, 3, 7, it chose to become something. The moment that it chose to become something is the moment that you get to see it. Other than that, it is unseen. Okay, now this plays a huge role, of course, in the Kabbalah and everything that we talk about from the seen and the unseen life, is that once it makes a decision, aka knows what you want and makes a choice, then you can see it as a particle of light. If it does not agree with it and it decides not to make a choice, it will stay unseen and you'll never see it. Your eye cannot observe a light wave. Okay, so it's absolutely fascinating that what he discovered is he discovered that these particles are alive. They're aware, they're conscious, they're sentient. They know that they are being observed. And they know that they're being observed not by just the observer, but by the curve of what's observing it. You see, because the only thing that your eye and a camera have in common is a fisheye curve. You have a curve over your eye, obviously, and you have a curve over a lens. The thing that I'm recording in has a curve, okay? So when light goes through a curve, it knows it's being observed. And once it knows it's being observed, it now can choose whether it wants to be seen or unseen. Okay, so we never actually see the wave of light. We see the after effect when it hits the wall. We can, however, see particles of light. And so therefore, we understood that it's choosing one or the other, because as long as there's no observer and he doesn't watch what is happening, you get both particle and wave interference patterns on your wall. But as soon as you turn around and you look at it, you observe it, then you get only one or the other, showing that it's making a choice. But even if you don't observe it and put in something that has that curve, it also knows that it's being observed and it chooses as well. Okay, this is absolutely fascinating stuff because of the fact that this was in 1801. They didn't even know what this could actually be. We're just now getting quantum computers up and running. We're just now hitting quantum supremacy. So in 1801, this was mind-blowing. And so this is the double slit experiment. It is a physicist who decided to take a photon gun, fire it through two different slits, and not observe it. And when he didn't observe it, he got both particles of light and wave patterns on his wall. Clearly, it's just going through and it's being both. But the moment he decided to observe it was the moment that it then chose one or the other. He only had a certain pattern on his wall. And when he decided not to observe it with his own eye and add in a camera that had a curve, he also ended up with either one or two. He did not have a wave and a particle. He only had a particle or a wave, okay? Showing that the observation itself, the curve itself, was telling this particle it is being observed. And once something is being observed, the very first thing it gets to decide to do is to be seen or not seen. Everybody has the ability to do this. You have the ability to be seen or not seen just by not leaving your house. If you don't want to interact with the world, you don't have to, and you make that choice. So it is important to realize that just as you make this choice, everything else in existence makes this choice. Okay, there is free will for all, but not everything has the same options. Okay, the one thing that everything in existence has a choice to do is to be seen or not seen. And this is the great power of the number 137. And this is one of the greatest secrets of the Kabbalah or the Zohar. All right, get your 9 vibes aligned.